I'm Anil Kumar, and here is a very important question on probability distribution. The question is, find the probability distribution for the number of doublets in 3 throws of a pair of dice. So we are working with a pair of dice and we are looking for doublets, right? So find the probability distribution for the number of doublets in 3 throws for a pair of dice. You can actually pause the video, answer the question, and then look into my suggestion. Now we are looking into probability distribution, and we'll try to make this as a binomial distribution, right? So the criteria here is to look into random variables which can have output as success or failure. Then it becomes very easy to solve. But let us first understand what are doublets when we throw a pair of dice, and that too 3 times. So when you throw a pair of dice, what can you get? You can get numbers 1 to 6 from one die. So we could get 1, 2, 3, 4, 5, 6. That is with one die. And with the other dice also, you can get the same numbers 1, 2, 3, 4, 5, 6, right? So the combination of each will be like this is 1, 1. Do you see this? So this combination is 1, 1, correct? And here we get 2, 1, but here we get 2, 2. And then we get, so all these points here, similarly 4, 4, and similarly 5, 5, and similarly 6, 6. So these combinations which we get, both dies giving you the same number. Do you see that? 3, 3, 4, 4, 5, 5, and 6, 6. These are called the doublets, right? And as such, how many numbers are we going to get? 36. 6 times 6, which is 36. So in this sample space, we have 36 outcomes. Do you see that? In every trial, right? So let's redefine our problem and let's have a look at this problem in a different way. It says find the probability distribution for a number of doublets in 3 throws of a pair of dice. So for us, the event is what? For us, event A is roll a pair of die. Is roll a pair of die. Okay. So when you roll a pair of dice, in that case, what is the probability of getting doublets? So that is small p, right? Small p, the probability of getting doublets. So we are saying let success be the probability of getting doublets, be small p, which is equal to 1, 2, 3, 4, 5, 6 out of 36. Or you can say 1 out of 6. This is the probability of success, which is doublets. So success is probability of doublet in each trial. So the small p is the probability of doublet in each trial. Correct? Is that clear to you? Now we are defining a random variable x. Capital X. This is the random variable. This is the random variable. How are we going to define random variable in this case? We are saying that a doublet is success. If you get a doublet in a trial, that is what x is. So doublet is a success, and what is x? X is number of doublets. X is number of doublets. Do you understand? So doublet is a success for us. So number of successes, number of doublets, which is a success. Let me write comma here. In n trials. Are you getting my point? Number of successes in n trials, correct? In n trials. And from where do we get this number n? This is an independent event. You can see every time you roll a die, so that is a trial. So when you repeat your experiment n number of times, it says 3 throws, right? So trials, there are 3 trials. There are 3 trials which can have 2 outcomes, either success or failure. And all these trials are independent. So we are looking into 3 trials which have only 2 outputs, success or failure, all are independent, where the probability of success is what? 1 out of 6, we just found, right? 1 out of 6, success. Failure will be 5 out of 6, correct? Because their combination should be 1. So this we write with lowercase p, and this we write with lowercase q, correct? So that is Bernoulli's trials. Is that okay? Now the question is, find the probability distribution for the number of doublets in 3 throws of a pair of dice. So when we say probability distribution, it means what? It means that for each value of x, we have to write down what is the probability of getting those many number of successes. Do you get the idea? So for this interval, for this independent variable x, which we have defined, the capital X, it could be equal to, so when you do 3 times, so we could get success 0 times, we could get success 1 time, we could get 2 times, or all 3 times. Is that okay? Now probability for, these are little x, right? So x, little x. So probability of each, that gives you probability density. So this column here gives you probability density. Is that clear to you? So this column gives you probability density. As we have seen here, it is Bernoulli's trials, and here we are talking about success or failure as the example of binomial distribution. Do you get the idea, right? So what are these? So each trial probability here will be P is success, Q is failure, no success, right? So that means all failures. So out of 3 trials, so it becomes 3C0, P to the power of 0, no success, and Q, all failures, right? This is what it is. The second term will be 3C1, P to the power of 1, Q to the power of 2, and then we have 3C2, P square Q, and then we have 3C3. Let me write PQ and Q to the power of 0. Do you see that? So that becomes the probability distribution in this particular case. Correct? So you can actually calculate the values with P as 1 over 6 and Q as 5 over 6. Correct? So if you substitute, you get your answer. Correct? You know, C30 is 1, P to the power of 0. So let me write down these values as 1 time, okay, this is 1 over 6 to the power of 0, and this is 5 over 6q. This is 3, right? 3, 1 over 6 to the power of 1, 5 over 6 to the power of square, and this is again 3, 1 over 6 to the power of 2, 5 over 6, and this will be 1, time 1 over 6 cube, and 5 over 6 to the power of 0. Is it okay? So that is what you get. Correct? So here it is 5 over 6 cube. So we can just calculate these values. So the first one is within bracket 5 divided by 6, and then we cube it, equals to, in decimals, 0.578. So let me write down this value as 0.578 8, 7, okay, 8, 7. The other one is within brackets 1 divided by 6 times 5 divided by 6 square, right? So square, which is equal to, in decimals, 0.115. Okay, now the second one here is, oh, we didn't multiply this by 3. Let me multiply this by 3. I was kind of surprised. So it is 0.3472. So this is 0.3472. Okay, and the last one here is 3 times within brackets 1 divided by 6, and then within brackets 5 divided by 6, bracket close. In decimals, it is 0.416. It is 0.4166. And the last one here is 1 divided by 6 whole cube, which is within brackets 0.0046, right? So that becomes the binomial distribution for the given case, right? So the possibility of, when you roll this die, not getting any doublet is 0.5784. Let us recalculate, no harm, right? 3 times we can put in brackets 1 divided by 6 times 5 divided by 6 whole square equals to, in decimals, 0.347. That's correct, right? So these are the probabilities which we get in this particular situation. So if you sketch this probability distribution, right, let us say if you sketch this, then for x equals to, this is capital X, right? So x could have value as 0, 1, 2, or 3, right? So you can say 0.5. So let's say this is 0.5 for us. So that becomes 0.5 for 0. Then 0.3, which is kind of, let's say, slightly more than half. So okay, this is 0.3 for us. And 0.4 is slightly higher than this, which is 0.4. And then a very small value here is kind of 0.0046. So this is the probability distribution for the given condition, right? So that is how we could actually sketch the probability distribution, and that is the binomial probability distribution. I hope that helps. Thank you and all the best. I need to calculate the value at 0. Let me calculate this again. 5 divided, within brackets, 5 divided by 6 whole cube is equals to, in the decimal, 0.578. That is correct. So that is what we see as the binomial distribution for the given case. So what do we summarize from here? In such a case, we could describe an event which was to roll a pair of dice. We know this event is independent event. Every time you do this event, you get the same probabilities for success as it is for other cases, right? In every roll, in every trial, we have the same probability of success. We define the variable, random variable, as doublet being a success, number of doublets being success in n trials. So x is actually the number of successes which you get, in our case, 3 trials, right? So in 3 trials, you could get 1 success, 0 success, 1 success, 2 or 3 successes. Now, based on the binomial distribution, we found the probability of each, probability when x is 0, probability when x is 1, probability when x is 2, probability when x is 3. Those values, when plotted as shown here, or when written in this table form, is what we mean by writing probability distribution, right? So when I say probability distribution, I mean to say either show your answer like this or like this. One of them is good enough, right? I hope that clears many things, many concepts. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.